Day 2 of Unit 1A. Today we are going to solve systems of equations using substitution. What we looked at yesterday when we solved the systems was we looked at solving the systems using elimination and using graphing. We said the easiest way ends up being there is Desmos became a nice little activity for us, a nice way to kind of solve using technology. Well, technology is not always going to be available, so we have to come up with a couple different ways to solve systems of equations. So today we're going to talk about substitution and how do we use substitution to solve systems of equations. This method is used quite often. It's probably not the most used one, but it's used and it works pretty well in given circumstances. Just to kind of remind you what substitution is. Let's say I have something like 3x plus 2y, and that's my expression. Okay. Let's say that I know my x values are 2, my x value is 2, and my y value is negative 4. We can use substitution then to evaluate this expression, replacing with what I know x is equal to and y is equal to, with where they fall into our expression 3x plus 2y. So I'm going to leave the 3 alone, but I know my x value is 2, so I'm going to substitute that x value with what I know it's equal to. It's 2. Plus 2 times what I know my y value is. My y value is negative 4. Now we can simplify. 3 times 2 is 6, plus 2 times negative 4 is negative 8. In remembering order of operations, you have to do multiplication before you do addition and subtraction. And then 6 plus negative 8 is negative 2. So that's the evaluation of that expression if I know my x value is 2 and my y value is negative 4. So that's substitution. We can use substitution to help us then solve systems of equations. So that says by elimination, but we're going to solve this system of equations by using substitution. So here are my two equations. I've got y is equal, so this is my system. I've got y is equal to 2x minus 1. That's my first equation. My second equation is 3x plus 2y is equal to 26. So I have these two equations. Yesterday we popped them into Desmos. We hit both of them in there. We found out where those two intersected, and we said that intersection point was the solution. Well, we're not going to use Desmos today to do this. We're going to use that substitution. So when you're using substitution, the first thing you're going to do, kind of the first step, is to make sure that one of the equations, whether it's equation 1 or equation 2, and I have a tendency to label them 1 and 2, just to kind of help me keep it in my mind, plus it helps me verbalize it to you a little bit better. One of those equations needs to be solved for x or y. It doesn't matter which one. It can be the first one, it can be the second one. As long as one of them is solved for x and y, or y, we can use substitution. So if we look in this case, equation number 1 has y is equal to 2x minus 1. So that's good. One of them is already solved for y. What that means then is we can go, in this case, into our second equation. 3x plus 2y equals 26. And anywhere we see a y value in there, I can replace that with what I know is equal to, y is equal to, which is 2x plus 1. This then is going to equal 26. So again, what I've done is I've taken this second equation, 3x plus 2y equals 26. I've rewritten it. And the only thing I've done is anywhere I've seen a y, I've replaced it with 2x minus 1 because I know that's what y is equal to. Now, if I look at my new equation, there's only one variable in there, x. And so my next thing I'm going to do with that equation, my newly written one, if we want to label that 3, we can probably label that 3. Don't need to do that. But we want to solve that equation for x. So I'm going to drop down that 3x plus I have to distribute this 2 into 2x. 2 times 2x is 4x. I also need to distribute that into negative 1. So 2 times negative 1 is negative 2. And now that has to equal 26. Now we're into solving equations. Combine like terms. We've done distributive. Now we combine like terms. 3x plus 4x is 7x. So that gives me 7x minus 2 equals 26. I'm solving the equation, so now I got to get my variables on one side, constants on the other. Add 2 to both sides. 7x equals 28. Now I can kind of think in my brain, 7 times what is 28? Well, 7 times 4 is 28. So I know my answer has to be 4. If I don't remember that, we'll divide both sides by 7. 28 divided by 7 is 4. So now I have my value for x. I know what x is equal to. The next step then is to take what I know x is equal to and substitute it into either of my 2 original equations. It doesn't matter which one I pick. I can pick equation 1 or I can pick equation 2. I'm going to pick equation 1. I'm going to pick the equation y is equal to 2x minus 1. The reason I do that is because it's already solved for y. All I have to do then is replace what I know my x value is for where I see x. So that's going to be 2 times 4 minus 1. 2 times 4 is 8. 8 minus 1 is 7. So y is equal to 7. So what this means then is that means that these 2 equations are going to intersect at the point 4, 7. And 4, 7 is the answer that I would expect you to give. Because remember, this is the point of intersection of these 2 graphs. This point 4, 7 should work for both equations. And I can check it. If I substitute 7 for y, that gives me 7 is equal to 2 times 4 minus 1. That's true. 3 times 4 plus 2 times 7, that's got to be 26. 12 plus 14 does equal 26, so it checks out. So that has to be my solution. And we talked about this yesterday. You can always see if your answers are right by checking them. Substitute those values back into your 2 original equations. And if they're both true, it works. If they're not, it don't work. Okay. So again, the steps. Step 1, solve for y. One of them, or x, whichever is the easiest thing to do. Once you've done that, substitute that in for your y value. Kind of create that equation number 3. Now that you've got equation number 3, solve that for your unknown variable. In this case, it was x. Once you've found the value of x, substitute that value into one of your first 2 original equations and solve. That gives you your point. Okay? So let's look at number 2. Number 2 has y is equal to x minus 1, and x plus y is equal to 7. Again, I'm going to label these 1 and 2 just for my ease of purposes and explaining. Notice equation 1 is already solved for y. We're in good shape. That means that in equation 2, I'm going to substitute the y value with x minus 1. I'm going to write everything else down. Putting it inside parentheses is a good habit. Doesn't always do anything for you, but it's a good habit. In this case, the parentheses make 0 sense at all. They might as well not be there. I have nothing to distribute in there. But it's a good habit to get into. Combine like terms. X plus x is 2x. That gives me 2x minus 1 equals 7. Isolate the variable, so I have to add 1 to both sides. 7 plus 1 is 8. Again, at this point, I just think to myself, 2 times what is 8? 2 times 4 is 8. So my solution's got to be 4. That's my x value. Again, if you have to show dividing both sides by 2, do that. That's okay. Now that I know what my x value is, I'm going to go back into equation 1 or 2 and substitute it in there. I'm going to do it in equation number 1 because it's already solved for y. So I'm going to replace my x with a 4. 4 minus 1 is 3. My y value is 3. Therefore, my solution for this, where do these two lines intersect? They intersect at the point 4, 3. Again, just check it. 3 plus 4 is 7. It works. Well, you know it works for the first one because that's what we substituted in there. So again, you always want to kind of just brush check these to make sure that you're good to go. It should always work. Okay? Questions with that one? All right, so get another one. So now in the next example, either of them is solved for x or y. So we've got 2x plus y equals 1 and 3x minus 5y equals negative 18. So in this case, the first thing we're going to want to do is we're going to want to solve that first equation for y. And I'm picking the first equation for y because that's the only one that has y alone. Otherwise, the other one has negative 5y. Yuck, solving for that. And it has 2x's and 3x's. Yuck, solving for that. So that's the easiest thing to solve for. So I'm going to take that equation, 2x plus y equals 1, and I'm going to solve it for y. So that means I subtract 2x from both sides. Left-hand side leaves me with just y. Right-hand side leaves me with negative 2x plus 1. I can't combine those. So now at this point, I'm going to kind of just cross this thing out because I've replaced that with y is equal to negative 2x plus 1. They're equivalent to each other. Now I can go ahead and solve by using substitution. Okay. So here's what I'm going to want you to do. I'm going to give you about 5 or 6 or 7 seconds to start. And then I'm going to start to go through it with you. If you think you know what's going on and you want to try to do it by yourself, get yourself started and just kind of shut me out for a couple seconds. The rest of you, if you still need help with it, I'm going to lead you through it in about 10 seconds. Okay, so I solved for y. I know y is equal to negative 2x plus 1. So in what was now my second equation, if I would have labeled them originally 1 and 2, I'm going to substitute into that second equation what I know y is. So that gives me minus 5, and then in parentheses, negative 2x plus 1. And that has to equal negative 18. Look through it, I've got one variable, okay? So now I have to solve for that variable. So distribute first. Negative 5 times negative 2x is positive 10x. Negative 5 times 1 is negative 5. That's going to be negative 18. Combine like terms. 13x. Now, kind of what's going through my head as I'm doing this, I'm kind of doing the math in my head to make sure I come up with a whole number. And it looks like I'm going to come up with a whole number. Does that always happen? No. Can you have fractions? Sure. But this looks pretty good. Isolate the variable, so I have to add 5. That gives me 13x equals negative 13. So again, in my head, I'm just doing this in my head. 13 times what is negative 13? Negative 1. Or you divide by 13. So you get x is equal to negative 1. So there's my x value. Now, I know what my x value is, so I'm going to substitute that x value into y is equal to negative 2x plus 1. I could substitute it into any of them. I could substitute it into the 3x minus 5y equals negative 18, or I could substitute it into the 2x plus y equals 1. Doesn't matter. I'm picking this one because it's already solved for y. So y is equal to negative 2 times negative 1 plus 1. 3. Last hour, for some reason, I put 4. Or so I did it again. That's 2. 2 plus 1 is 3. So my y value is 3. My solution then for this is negative 1, 3. And there it is. And you're done. Any questions with that one? And there's kind of our solution for that one. It's kind of a bad spot, but it works. Okay. All right, question number 4. Question number 4 is 2y plus x equals 4, and 3x minus 4y equals 7. In this case, it's easier to solve that first equation for x. So I would solve that first equation for x. So go ahead, solve that first equation for x, and then use what you have for x, substitute that into the second equation, find your value of y, substitute that back in, see what your value of x is. See if you can complete this one on your own. Give you about 2 or 3 minutes. I'll kind of go through here and solve it quietly in about a minute, and then you can check your work from that. Okay, when you get it done, if you just want to kind of peek up, see how I did it, see how you did. I'll explain it in just a second. All right, so I started out by solving for x. So I subtracted 2y from each other side. So I have x is equal to negative 2y plus 4. I then went to equation number 2, and anywhere I seen an x, I replaced it with 2y plus 4. I distributed. 3 times negative 2y is negative 6y. 4 times 3 is 12. Just wrote down the rest of it. Combined like terms, negative 4 and negative 6 is negative 10. Brought down the 12 and the 7. I subtracted 12 from both sides to get negative 5. Divided by negative 10 and got y is equal to 1/2. Thought, okay, that's fine. So I took that 1/2 and put it in my equation. Negative 2 times 1/2 is negative 1. Negative 1 plus 4 is 3. Thought, okay, so that makes my solution 3 negative 1/2. I wanted to check, I got a fraction. Fractions are okay, there's nothing wrong with them. So I wanted to check to see if I was right. So I took it into that second equation, that 3 minus 4y. 3 times 3 is 9. Negative 4 times 2 is negative 2. That does, in fact, equal 7. So, therefore, that's my solution. Okay. It's always a good idea to check. It doesn't hurt. I don't know. Whatever. Okay. Questions with that one? All right. So, the last two I want to look at are special cases. Okay, so, in the first one, I've got y is equal to 5x plus 3, and 5x minus y is equal to negative 7. Again, if we go through the process, step 1, make sure one of them, first or second one, doesn't matter, is solved for y. First one solved for y. Since first one is solved for y, in my second equation, anywhere I see a y, I'm going to put 5x plus 3 inside of parentheses and just write everything else down. Now, this is why it's so important that you put it inside parentheses. Because the first one I leave alone, but now I need to distribute that negative. Negative times 5x is negative 5x. Negative times 3 is negative 3. That's got to be negative 7. Combine like terms. 5x minus 5, that goes away. That gives you negative 3 equals negative 7. This is false. Negative 3 doesn't equal 7. Negative 7. So therefore there are no solutions to this. If there are no solutions, what does that mean? What are they to each other? Are they the same line or are they parallel? Parallel. They're parallel. They don't hit each other. I was reading a documentary yesterday that you can never accurately draw parallel lines. They're eventually going to intersect. It's what math people do sometimes. Second one, 2x minus 2y equals negative 10, and y is equal to x plus 5. Now notice the first difference in this one from any of them that we've done. The second equation is already solved for y. That's okay. Doesn't matter which one solved for y or which one you solve for y or x. As long as one of them is, we're good to go. So now, instead of substituting 1 into 2, I'm going to substitute 2 into 1. So that's going to give me 2x minus 2. My y value is x plus 5. That's going to be negative 10. So I'm rewriting the first equation this time, and that's okay. Distribute 2x minus 2x minus 10 equals negative 10. Combine like terms. That's negative 10 equals negative 10. That's true. That means they're the same line. So there are infinitely many solutions to this. If 5, 0 is a solution for the first one, 5, 0 is a solution for the second one, or 0, 5, sorry. 0, 5 is a solution for the first one, 0, 5 is a solution for the second one. There's lots of answers you could have for this. Okay. So that's what you're going to work on today. You're going to work on solving systems of equations by using substitution. Okay. Again, the steps you're going to use. Solve one of the equations, either the first or the second, for x or y, if it's not done for you already. Once you've done that, substitute that one you've substituted into the other equation. Solve that equation for that unknown variable. Once you've got that unknown variable, substitute that back into the original equation and solve for the other unknown. That becomes your point of intersection alphabetically.